So here I have an example of a lab I did with my class today, and I just picked 3 of the labs to show because it was at different parts of the lab. And it's showing Bronsted-Lowry and predicting reactions and then testing those reactions out. So for the first one we're taking a look at, we had sodium hydrogen carbonate reacting with sodium hydrogen sulfate. So with all Bronsted-Lowry reactions, you want to list what you have and predict whether you have acids or bases. So we break up what we can. So you have sodium ion, the hydrogen carbonate ion. You also have the sodium once more, which we didn't have to list twice. And you have the sulfate, hydrogen sulfate ion. Because it's all in solution, water would also be present. So you go through, sodium is not on your acids chart. HCO3 you will find on both sides. It's an acid and a base. HSO4 negative, same thing. And water, same thing. So then you start looking at your chart, and your strongest acid is HSO4 negative. So that's one that will be reacting. And so I'm just looking at my acids column and whichever I see first starting from my top left. Then I look at my bases column, and whatever I see first starting from the bottom right, I will know is my strongest. So that would be the HCO3 negative. So now that we have that, we want to predict the reaction. So your strongest acid reacts with your strongest base. And now, because both of these are weak acids and bases, your reaction is in equilibrium. And now we can show the hydrogen going over to the base. When hydrogen leaves our HSO4 negative, it will also leave with a positive charge. So SO4 will get more negative. When HCO3 negative gains a hydrogen, there will now be 2 of them, and it will also gain a charge and become neutralized. Now, this is the first part. With this, you always have to predict. So when we're predicting what's being favored, it's based on placement. Your acid is higher than your base, so that means your products are being favored. And now we can go to the prediction that gave us some extra information that says carbonic acid decomposes into water and carbon dioxide gas. And then it says, will you see bubbles? So because our product is being favored and carbonic acid is one of our products, that is what will decompose into water and carbon dioxide gas. So because a reaction lies on the right-hand side, this will happen. We will see bubbles because bubbles will form if there is a gas. So you would say yes. Now, if the same situation happened, but the reaction laid onto the left-hand side, reactants being favored, then you wouldn't, because that's H2CO3 wouldn't be on the correct side. So it's on the side we need it. It's being formed. Because of that, we should see bubbles. And then that brings me to the picture of the lab. And in this lab, it just shows that I am mixing the sodium hydrogen carbonate with the sodium hydrogen sulfate. And I'm putting it into this top right-hand corner of my well plate. And when I've mixed the two, I see those bubbles. And that is my carbon dioxide gas that was being formed. So that was our first reaction, just proving what we should see. The second reaction that we took a look at, we had sodium benzoate solution mixed with sodium hydrogen sulfate. So I'm starting with the same thing. I want to list everything I have. So I have sodium positive and C6H5COO negative. Sorry about that. So I'm seeing right here is my benzoate ion, and I also have more sodium, and then the hydrogen sulfate ion once again, and both are in solution, so I have water. So going through your strongest acid and your strongest base, going through that list like we would have been before, we would see that HSO4 is reacting with the benzoate ion. So let's write that out. HSO4 negative, add C6H5COO. Your arrows in both directions because they're both weak. The hydrogen, sorry, my hand just keeps swiping that. The hydrogen is going to go over to the base. So when the first one loses a hydrogen, it will also lose that positive charge, making it more negative. And then that C6H5COO, when it gains the hydrogen, it will become neutral. So that's what we have in terms of our predicted reaction. And now going to that information. Benzoic acid is highly insoluble, will a precipitate form. Now, it depends on what side we see it. So we see benzoic acid on the right-hand side. So if our products are favored, we should see a precipitate form. So we have our acid higher than our base, once again, based on our chart. So products are favored. So if products are favored, we definitely have that benzoic acid being formed. So we should see a precipitate. So when I came over to this example, I have the two solutions I'm mixing together. I did pick the well plate. I tried to show that each solution was there clear. And then when the two got mixed, and this is just an awful picture, but you do see a solid being formed. And that solid would be that benzoic acid making that precipitate. Now, the last reaction we took a look at was one that involved an indicator. And indicators, you can figure out where they belong on your acids page. And then we can apply that same information. So when you do take a look at your indicators, you see that you have essentially like a buffered solution. You have your acid belonging with your base with the color, and you have a Ka value. So this column is showing your Kas. So when we want to predict, we can tell where this goes based on your Ka values on page 8 and 9. So because we have this 5.0 times 10 to the negative 8, this would be higher up on the table than all these values of negative 10, negative 11, negative 12. So I know roughly where I could find bromothymol blue if it were to be on page 8 and 9, our acids page. So with this, I am mixing the negative base part of bromothymol blue with sodium hydrogen carbonate. So that's going to react with the hydrogen carbonate ion once again, and I still can list it all out and see what I have. But this time hydrogen carbonate is acting like an acid, and the BB negative is going to be the base part. So hydrogen's going to go over because that negative ion on BB will attract it. And our arrow once again will go in both directions because it's in equilibrium and we have nothing strong. So once the hydrogen goes over, you get that HBB and you have CO3 negative 2. So with our predicted reaction and knowing where we would find bromothymol blue if it was a base, where you can look at our colors. So this BB color, it is associated with the blue. So this side of our reaction will be blue. The HBB, where we find it, that is associated with that yellow color. Now, because our base, which is here, is higher than the acid based on the Ka values, your reactants are favored. So when we do this, we should see a more blue color instead of a yellow color. If it was more yellow, that would assume that we had more of an acid present. So let's take a look at that. So I should go back here. So we should predict it would be blue because reactants are favored, and that's the blue side. So coming over here, I just showed we have the indicator, hard to see, but that's bromothymol blue. We have the sodium hydrogen carbonate. I have put it in the well, just showing bromothymol blue by itself. And then when I took a look and I added both together, it is that blue color. And now I just wanted to show that, just because that blue is very overpowering, that the indicator was there. And if I took, and this flipped it, but this is HCl. So if I did take that acid and add it right into this well, you will see that it is turning yellow. And that's just because I am shifting and creating more of an acid in that reaction, making that yellow color. So I hope you found this helpful. If you did, please like and subscribe to this channel. And if there's any type of video that you would like to see, please write that in the comments. Thank you for watching.